Hello students, welcome to my channel again. So today we are going to start a new chapter. The name of the chapter is electrostatics, and today it is the first lecture of this chapter. So let us first of all define what is electrostatics. As you can see, I have already written the definition of the electrostatics. It is defined as the branch of physics which deals with the study of properties of charges at rest. So in this chapter we will be just discussing various charged particles, and these charged particles will be at rest in our frame of reference, and we will see how these particles at rest interact with each other. So this will be the means you can see theme of this chapter. So let us now first of all see why the concept of charge is needed in physics. Let us now give the answer to this question. So you can see I have shown here one example. Here these two dots are actually protons. These are separated by small distance r in free space, and we do not have the knowledge of any other force except the gravitational force which we have studied previously to this chapter. So it means we only have the knowledge of gravitational force, and we know that gravitational force is attractive. So if two particles of any mass are placed near each other, then these two masses attract each other with a force which is given by this expression. If the two particles are of equal mass, then the expression will become this. Now both are protons and their mass is supposed to be equal, that is m. So the gravitational attraction between them is this. So mass of each proton is given here. The value of universal gravitational constant is given here, or you can assume yourself. And if we find this value, because of this value in the free space, these two protons must attract each other. So these red arrows are actually the force directions, force of gravitation. So these are the directions of gravitational force. So these two protons will attract each other, and since these protons are closer, are placed in the free space, therefore these must come closer to each other, because in free space nobody there is nothing who can stop these protons from moving. So however, if experiment is done to verify this problem, then we just observe the opposite. Let me now describe what is observed practically. This is something which our mind will tell to us if we have the knowledge of only attractive gravitational force. Okay, in the real sense, if the two protons are placed closer to each other in the free space, then it is observed that actually these two protons repel each other. So the forces on these are actually away from each other. So this is a repulsive force. And from where this repulsion is coming, it is a question mark for us, only up to that point for which we do not have the knowledge of the charge. So in the purview of, or in the context of gravitational force, we cannot give answer to this experimental observation that when two protons are placed close to each other in free space, then why they repel each other. We are unable to answer this experimental observation. So to give the answer to this interaction between two protons and many other interactions which could not be explained with the sole knowledge of gravitational force, we have to introduce the concept of charge in the world of physics. So therefore we now are just capable of understanding that there is a need of defining another property of the matter. This property of the matter we will name as charge. The initial property of the matter, we know that it is mass. Mass is the fundamental property of every material particle, and we also know its definition. It is defined as the quantity of matter contained in a body. However, we will be seeing, we have to assume or assert that just every particle possesses mass. In the same way, every particle possesses another quantity. That quantity is called charge, and this is also the fundamental property of every particle. Let us now define charge. You can see here I have given the definition of the charge. It is defined as the fundamental property of every material particle in terms of which certain interactions between the particles can be successfully explained. So you just remember this definition. I have also written here that these properties are otherwise unexplainable with the knowledge of gravitational force alone, because you can see here in this example, with the knowledge of gravitational force we cannot give the answer to the question that why two protons repel each other. However, if we understand or introduce the concept of the charge in the physics world, then we can very easily give the answer to this question. So therefore we have to define charge, and by defining charge we have to now understand it on the basis of the experiments, and these experiments will help us in explaining the properties that the charge will possess. Let us now go to the next part where we will discuss the properties of the charge, and after that we will come to this example again. So in this topic, the properties of charge, I have written the first property of the charge. So you can see here that the charge is of two types. The first type of the charge is called vitreous. Classically, or in the older times, it was called vitreous, but nowadays this name has been replaced by new name that is called positive, and resinous. Resinous is now called negative. So now we will be sticking these two to these two names, that is positive and negative, because vitreous and resinous are only the historical names of the two types of the charges. These are no longer used in the literature, so we will stick to two kinds of charges, and we will stick to the names as positive and negative. One thing we can be just say that there are certain bodies which are neutral actually. So then you can have charge as positive, negative and 0, but we will not consider 0 as a type of charge, because a neutral body has neutral body has equal amount of positive and negative charge. So it means you can have, let us say, we know that the unit of the charge will be coulomb. So if if I have a body in which there are two particles, one of them has charge 5 coulomb, other has charge minus 5 coulomb, then the net charge on the body will be 0. So this body will be neutral, but neutral does not mean that it has no charge. Neutral actually indicates that it has equal amount of positive and negative charge embedded in it. So therefore the types of charges are actually two. There are not three types of charges. There are only two types of charges, that is positive and negative. 0 is not considered to be a type of charge. So let us now go to the second property. The second property is written here. It says that charge is a scalar quantity. So, but please remember that charge does possess a sign, that as I have written already in the property number 1. So charge can be positive or negative. It can also be 0, but that will be the result of equal amount of positive and negative charges. So please remember, charge possesses magnitude and sign. but it has no direction. Charge does not have any direction. So this is the second property of the charge. Let us now write the third property of charge. The third property says that charge is additive in nature. That is, the total charge on the body is equal to algebraic sum of the charges of its constituent particles with proper signs. So the sign of the charge is very important, that you must remember. For example, if there are three particles, let us say these three particles, these combine together, let us say these three particles combine together to make a new body, and suppose the charge on this is, let us say, minus 5 coulomb, charge on it is 8 coulomb, let us say charge on it is 2 coulomb, then the charge on this final body, which is formed from these three constituent particles, will be actually minus 5 plus 8 plus 2, that will be equal to plus 5 coulomb. So this is the meaning of third property, that charge is additive in nature. So to find the total charge on a system containing a large number of constituent particles, we will just add the charges of all constituent particles algebraically. However, while doing this, we will not ignore the sign of the charge. The sign of each charge must be taken care of properly. The fourth property of the charges is that similar charges repel each other while opposite charges attract each other. So, to understand this property, I will show you some experimental demonstration in which this we can verify that similar charges repel each other and opposite charges attract each other. For that, I have drawn a table here in the side, that when you rub a glass rod with silk cloth, then glass rod gets positive charge, while silk cloth gets a negative charge. So I will come to this topic in my second lecture also. For the time being, you assume that it happens, because frictional electricity is not my today's topic. It will be in the next lecture. So for the time being, just assume it. Similarly, when we rub a woolen cloth with ebonite rod or with amber rod or with rubber rod, then woolen cloth gets negatively charged and ebonite rod, amber rod or rubber rod gets positively charged. In the same way, if dry hairs are rubbed with comb, then the comb gets negative charge and hair get positive charge. So this is just an example for reference. Now let me draw the experimental activity in which we can verify that the similar charges repel each other and opposite charges attract each other. So I have drawn here an example. In the A part of the example, I have shown a glass rod which has been rubbed with silk cloth and it is suspended from a roof with the help of a thread. The glass rod is free to move in a horizontal plane. So I have another glass rod which is also rubbed with a silk cloth. So both of these glass rods will have positive charge as per this table. So when you will bring this glass rod near to one of the free end of the suspended rod, then it will be observed that the free end of the suspended rod will experience a force away from the glass rod which is in your hand. So which clearly indicates that there is a repulsion between the two rods. Since the two rods have the same charge, so therefore they repel each other. In the same way, we can do the same experiment. Instead of with glass rod, we can do the same experiment with ebonite rod. Rub the ebonite rod with woolen cloth. Now, as per this table, when we will rub ebonite rod with woolen cloth, then the ebonite rod will get a negative charge. Now, suspend one of the ebonite rod and bring another ebonite rod closer to one of the free end of the suspended ebonite rod, and you will see that the free end of the suspended ebonite rod will be deflected away from this rod. So with this experimental activity, in which I have shown in part A and B, we can very easily verify that the similar charges repel each other. Now I have shown two another diagrams, that is C and D. In the figure C, you can see glass rod is suspended, but we are now bringing an ebonite rod close to the free end of the glass rod, and it can be seen very easily by doing this experiment at your home that the free end of the glass rod will be deflected toward the ebonite rod. Similarly, in the ebonite, in the active figure number D, we have suspended ebonite rod, but now a glass rod is brought closer to the free end of the ebonite rod, and just as in activity C, now the free end of the ebonite rod will be attracted toward the glass rod. So we can see from activities A, B, C and D that positive and positive charges repel each other, negative and negative are also repelling each other, while positive and negative attract each other. So with this small activity, we can verify that similar charges repel each other and opposite charges attract each other. Let us now go to the next property. The fifth property of charge is that charge is always quantized. So you can also assume it to be like that the charge possesses graininess. Just as the grains of sand are there, each sand grain is complete in itself and it is different from its next sand grain. So we can count these sand grains. In the same way, charge also shows graininess, and whenever charge transfer takes place from one body to another body or from one system to another system, then it always takes place in terms of integral multiples of some fundamental value or the smallest possible charge. The smallest possible charge that we use for high school students is E. That value of E is actually the magnitude of the charge on electron, that is 1.6 into 10 raised to power minus 19 coulomb. So you must remember this, and suppose a body has got charge Q, capital Q, from another body, then the charge capital Q must be an integral multiple of the smallest possible charge, which is E, that is the magnitude of the charge on the electron. So the value of N can be 0 or plus minus 1 or plus minus 2 or plus minus 3 and so on. It means that always you will have no transfer of electron, or one electron will be transferred, or two electrons will be transferred, or three electrons will be transferred from one body to another body. Fractions will not be possible. However, when you will go to the higher classes after completing your school studies, you will find that the smallest possible charge is not actually E, it is actually 1 by 3E, which is on another particle which is called quark. So quarks can have four kind of charges, that is 1 by 3E, minus 1 by 3E, that is 2 by 3E, and minus 2 by 3E. But we do not consider it for school students. It is because of the fact that quarks do not have independent existence in this world. So far, we have not been able to separate quarks from each other. On the other hand, isolated electrons have been found. So therefore, for you, you can assume that the smallest possible charge is E. So Q is always an integral multiple of E and charge is always quantized. Let us now go to the sixth and the last property of the charge. The sixth and the last property of charge that I would like to introduce to you is that charge is always conserved in any physical or chemical process. So, to understand this, we will take the example of a famous nuclear fission reaction in which we know that a neutron hits fissionable uranium, that is 92U35 235, and in this process, when the fission takes place, the uranium nucleus breaks into three fragments. First one is krypton, second is barium, and third fragment is actually 3 neutrons, and in this reaction of the order of 200 mega electron volt energy is also produced. But please remember, it is pure form of energy. So the material particles which are produced during this fission are actually krypton, barium and neutron only. Now please remember, in case of any nucleus, suppose X is the symbol of the nucleus, the number at the bottom is called atomic number and the number at the top is called mass number. So the charge on nucleus is found by a very simple rule. Charge on nucleus is actually Z multiplied by E. So you can see in this nuclear fission process, the initial charge before the fission takes place is actually 0E plus 92E, which is actually 92E, and the final charge after the fission has taken place can be easily calculated by using this formula or this rule, that the final charge after fission will be actually 36E plus 56E plus 3 multiplied by 0E, which will again be 92E. You can see that the charge after this physical process, rather it is a nuclear process, is equal to charge before this nuclear process. So this is an example where the charge conservation has been shown to be verified, but it is actually verified in all sorts of physical or chemical processes. Let us now go to the initial example that I have taken in the start of my lecture, and with the help of the properties that we have just studied so far related with the charge, let us now try to explain why two protons repel each other. And this answer to this question could not be given with the help of gravitational force alone, but the answer to this question could be very easily given with the help of knowledge of charge and the properties of the charges. So I have now returned to the first page of this lecture or of this slide show. So you can see this repulsive force, which could not be otherwise explainable with the help of gravitational force. Now we remember that the similar charges repel each other. Since the particles in the question are protons and the charge on proton is positive, and therefore both of these protons will repel each other because of the same sign of charge. Also, it should be clear that the gravitational force is still present between the protons. These two protons are still attracting each other because of their gravitational force. However, the gravitational force is a weak force as compared to the this repulsive force between the protons because of the charge, because similar charges repel each other. So the force between the charges is called electrostatic force. Force between the charges is called electrostatic force, while the force between the masses is called gravitational force. So this electrostatic force is of the order of 10 raised to power 38 times stronger than this gravitational force. So although this gravitational force is present between the two protons, but due to huge magnitude of the stronger repulsive force between the protons, the overall effect is that the two protons will repel each other. So it is very easy for understanding that from the concept of charges, that why two protons repel each other. And there are so many other examples which can be very easily explained by just understanding the concept of charge. And the concept of charges introduces a new branch of physics to us, that is electrostatics. Later on, electricity and even then magnetism was developed from the concept of charge alone. So I think I should stop here now. In the next lecture, we will discuss frictional electricity and the methods in which a body can be charged in detail. So till then, it's goodbye from me. Thank you. Thanks a lot.